Lesson 2. In Lesson 2, I'd like to begin by opening up the MODFLOW project file that we used in Lesson 1. So let's go up to the File. Now in my case, I can find the Lesson 1 file in the recent file list. If it's not there for you, you'll have to navigate using your browser to find where you place that file, but for me it's right here in the recent file list. And there we see a outline of the domain. Why don't we go to the Input tab to remind us what the grid looked like, and there it is. This aquifer is 1,000 feet from the bottom edge here in the Y direction, and it's 2,000 feet long in the X direction, and then it's 100 feet thick. Let's look at the cross section. You can see the aquifer is 100 feet thick. And in this problem we had steady state groundwater flow. It was an unconfined aquifer. Let's go ahead and run this problem again to make sure that we have all the data we need for our next steps. So we'll go to the main menu and we'll run the program, keeping all the default MODFLOW settings the same. We can just go over to run and say translate and run. Alright, it's just what we did last time. Let's take a look at the output. You see here contour lines of head, and you see velocity vectors. Remember that in this problem we had a specified head or constant head boundary in this region of 90 feet. The aquifer is 100 feet thick, so this indicates it's an unconfined aquifer. And then over in this region we had a specified head boundary of 70 feet. See our velocity vectors here. I'm going to go ahead and edit these contour lines for head by putting them back at an interval of 1 foot, so that we can see a little more detail of our solution. So you should have something that looks very similar to this. And now I'd like to show you how to use pumping wells with MODFLOW. So let's go back to the main menu, go to Input, and now we're going to use the Wells tab up here, so go ahead and click on that. And when we do, it lets us choose between pumping wells and head observation wells. Pumping wells put water into or remove water from the aquifer. Head observation wells are used just to record computed water levels from points in the grid. In a steady state flow problem, there's not much use in using head observation wells. Really more useful with transient flow problems, but we'll see that in a little bit. Alright, so let's go select pumping wells. And now this tab is changed from grid and other features to pumping wells. And I'd like to go ahead and add a well. So I'll just click Add Well. And then I'll move my cursor out into the grid and pick a location where I want the well to be. I can just be approximate in this because now I have the chance to set the coordinates exactly where I want them. So we'll just call this well 1. And why don't we put it at 650 feet in the X direction and 300 feet in the Y direction, so we know exactly where it is. Now we have to define where the well screen. To do that in MODFLOW we have this little graphic that helps us. Here's the bottom of the aquifer, so that's Z equals 0. And here's the top of the aquifer and the land surface at Z equals 100. So the top of our well screen, I'm going to place it 100 feet. I'm going to make a fully penetrating well. And the bottom, I'm going to go ahead and set to 0. And so you see the image shows us the well screen. It's the fully penetrating well. Now in terms of the pumping schedule, we'll start on day 0. And because we're doing a steady state flow problem, again, this is pumping continuously, but I'll go ahead and pick the same steady state simulation time we've used before, which is 1 day. And for pumping rate, I'm going to choose kind of a small value, and then we'll vary it to see the effect. And the convention here is positive means water is being pumped into the aquifer, or negative means water is being pumped out of the aquifer. Let's go ahead and pump out at 200 cubic feet per day. We'll say OK. And there's our well. Now if we wanted to change the properties, we can use the Edit Well feature, where we would click on Edit Well, put our cursor over the dot for the well, and open it up, and so we can change these things. Or if we wanted to delete the well, we could simply click this tab, delete a single well, and then click on it here, and it will go away, like so. Alright, so we'll go ahead and add our well. Put it at 650, oops, and 300. Put the top of the well screen at 100 feet. Put the bottom of the well screen at z equals 0. And then the start day will be 0, the end day will be 1 day, and then we're going to be pumping out at 200 cubic feet per day. And so now I can say, go ahead. This error message won't affect us here. Later, when we do transient flow simulations, we'll be able to have pumps turn on and off for different periods of time, and so then we'll have a more complicated pumping schedule. But for today, we can just ignore that and go ahead and set up our well like this. And now it'll be pumping water out of the aquifer from this location. Let's run this model and see what it looks like. So I went back to the main menu, hit the Run tab, and now hit Run again. The model's running away. And now we can look at the output. And there we have the contour map of head with the velocity vectors, and we see the impact of the well pumping. It's lowering head in this region, causing some groundwater flow to change trajectory in the vicinity of the well. We can zoom in. Remember how we do that? We click the zoom in button and come in a little closer, like so. Should also mention that if we want, we can right-click here. Let me zoom out first. Right-click, and we can add some contour lines. So if we want to look at a little more detail in the vicinity of the well, we can say add a contour line, and then click wherever we'd like a little more detail. And then these, of course, will be small changes. Now, here I have elected to label these contour lines with zero numbers to the right of the decimal point. So if I want to see the actual numerical value of these contour lines, I have to go up to Options and then add 1 or more numbers to the right of the decimal point if we want to see their numerical values as here. And then if we want to delete those extra contour lines, we can right-click somewhere in the grid, and then we can just pick the ones we want to have go away, and maybe those. Alright, so we're back to where we started. Now, why don't we see what would happen if we increase the pumping rate from this well. So let's go back to the main menu. Input, then select wells, pumping wells again, to bring up this menu. And now we can edit the well, so I click there, and then I put the cursor over the well and I edit it. And now I'm going to increase the pumping rate by a factor of 10. That's the only change I'll make, so I'll say OK. Go back to the main menu, run the program, run again, and run. We've increased the pumping rate, so look at the output. We expect to have a greater decrease in total head, and you see that is in fact the case. Zooming in a little bit, we see head has dropped very low in the well. Remember, this aquifer is 100 feet thick, and here this one contour shows that the head is only 15 feet, so it's very close to completely dewatering the aquifer. Let's zoom out. Alright, let's go back to the main menu. Go to input. And now we see our grid. And we don't see our results, so let's remember how we can annotate the field we're looking at. So if we go to overlay, these are the things that are currently showing. We have the grid lines, we have some general annotation. Contour labels are for solute transport problems. We don't even have to have that clicked because of course there isn't any solute transport in this problem, but we can go ahead and turn on the wells. And if we apply, we'll see our well appear. And then if we like, we can put on the constant head boundaries by clicking here, adding that to the overlay. We see them. All right. And so now we can start to interact with the model in a way to display those features we're looking for. That's okay for now. Okay, let's go ahead and edit this well. So remember how we do that. We go to wells, pumping wells to bring up this menu. And we can go ahead and edit our well. Now remember that a pumping rate of 2,000 cubic feet per day out of the aquifer came very close to fully dewatering the aquifer. Well, what happens if we do dewater the aquifer? So let's go ahead and make that 5,000 cubic feet per day out, minus 5,000. And now let's run the model again. Okay, now let's go look at the output. And you see this green patch has developed. And if you look at the velocity vectors, they're bypassing this region. Because we're pumping so hard, we essentially dewatered this portion of the aquifer. MODFLOW lets us know that with this green shading. And so this is basically a dry patch. And so now water is flowing through coming in through this constant head boundary and then avoiding that region and going out. All right, so this is a clue to you that you've specified pumping rate that's too high for the given aquifer thickness and hydraulic conductivity. So let's go back to the main menu. Go to input. let's change that pumping rate in that well. Go to wells, pumping wells, edit the well, click on it to bring it up, and let's take this pumping rate down to 200 cubic feet per day out. This is the initial case we started with. While we're at it, why don't we add another well? So let's go over here to under pumping wells and click add well. And let's just put it somewhere over here. Let's call this well 2. And let's put it at 1,000 in the X direction and 700 in the Y direction. We'll make this a fully penetrating well too by setting the top of the screen at 100 feet, the bottom of the screen at 0. We'll start at day 0, end at day 1 in the steady state problem. And now let's pump in. So we're going to enter a positive number of 500 cubic feet per day. Then say OK. We see our 2 wells. Let's go ahead and run the model. So go back to the main menu, go to run, run again, and run. After it's completed running, we can hit the close button and go to output. Alright, so now we see the effect of 2 wells pumping. We have the extraction well here. You can tell it's an extraction well by the direction of the groundwater velocity vectors. We have an injection well here, and you can see similarly that water is leaving the vicinity of that well. We can go ahead in and add some contour lines by right-clicking to bring up the Add Contour option, and then add a few. Get a little more detail. Or we can go ahead and delete those by just right-clicking and continuing that process. Now, why don't we go ahead and look at the effect of these wells and this boundary conditions on the flow field in cross-section. So we have head selected here, so we can go up and view a row and select some location within the grid to look at a cross-section. Why don't I go right through here? Now it's a little hard to see, so I'm going to use the vertical exaggeration, and I'm going to make it a factor of 3. And now here, this is a very nice view. We can see what's happening in our aquifer. Remember again, the aquifer is 100 feet thick. Our constant head boundaries were 90 and 70, so the aquifer is unconfined, and this line is the position of the water table. And the green kind of exaggerates that, so up here we're above the water table, and down here we're below the water table. And this blue line is the water table elevation reference to the base of the aquifer. Here's the location of our injection well, and you can see that the water table has come up there as we expect. We can also see the velocity vectors in this slice, showing us that near the well the velocities are large, and as we get farther from the well they get smaller. And we also see the vertical projection of the head contour lines. Those are these lines here. All right. So let's go back and view it from above again. Now we can take a slice through the aquifer parallel to the y direction, so let's say view column and move through this well. And here again we see our well with the well screen. We see the cell that contains that well shaded brown. We see the position of the water table being slightly decreased by the pumping from this well. We see the velocity vectors and hydraulic head contours. And it's a very nice view of the problem. So let's go back and view the layer. So we've seen what happens when you pump at a rate that the aquifer can't sustain. It's just as we know happens in real life. The water table decreases and eventually the aquifer becomes unsaturated. What happens when we increase the pumping rate so much that we raise the water table above the land surface? Well, why don't we see that? Let's go to the main menu, go to input, go to wells, select pumping wells, edit a well, and let's go to well 2 here. It was pumping at 500 cubic feet per day. Let's increase that to 5,000 cubic feet per day. Say OK. Then go back to the main menu and run the model. So we go main menu, run, run, run. Go ahead and close. Look at the output. Now we see we have definitely impacted the flow field quite a bit. We've created a mound here. Let's go ahead and look at that in cross-section. And you can see that the water table has reached the land surface in this case. We've raised the water table very close to the land surface, hundreds of feet from the well. Let's look at the layer view. Now, of course, one could imagine that we're injecting under pressure and that we have a pipe going up. MODFLOW delivers that water to the mesh. Let's go ahead and look at some of these head contours. So we'll right-click within the domain and add some contours. Let's go ahead and label those to see how big these are. And you see that the maximum value of head is 140 feet, which is 40 feet above the land surface. Let's decrease the number of decimals visible. The interval's at 10 feet. And then we're done. All right, so now you have seen how you can use extraction wells and injection wells to control the flow field. This will be very useful for you when we try to design capture zones for extraction wells, or we use injection wells for hydraulic barrier purposes, or if we want to look at the effect of one well on another. So that's what we did in lesson 2. Why don't we save this? And then we'll end lesson 2 and we'll start on lesson 3 next time.